Now suppose we want to generate this figure 5.4, where we vary the cutoff probability from 0 through 1 and then see what the accuracy values are. So its accuracy is going to go from 50% to 50%, because if in this case there are 50% owner, 50% non-owner. So if you cutoff of 0 would mean that you classify everything as owner. If you set it as 100%, you'll set up everything as non-owner. So you'll be 50% right. So if you change the cutoff, then your accuracy, it kind of goes up and down. And the bottom line is the error rate. Error rate is 1 minus accuracy. So how do we do that? Okay. So what we need to do is to accumulate the accuracy value by running this code repeatedly for different cutoff values. Okay. Now first we have to see how to peel off the accuracy value. So you have confusion matrix that generates a list like this, and we need to look at accuracy, read the accuracy out of it, right? So we need to first save the result of confusion matrix into a list. So here, say, put it into CM. Okay. So once you do that, then we can go to CM and take a look at what it has inside it. So inside it, you have overall. So this is the overall has. Okay. So now if you go to CM, you see overall has several. It's overall itself is a list. Overall has a list of items: accuracy, kappa, accuracy lower, accuracy upper, and so on. So it's the first item of that list is what we want. So if you do cm.overall, and since it's a list, you specify the index within square bracket, then that will give you the accuracy right there. Okay. So we need to run these two repeatedly for different values of cutoff, and then look at what CM $overall 1 is and put that into another list. So what we're going to do is, okay, so the command for that is for, okay, so we can say cutoff. Okay, we do a sequence. Okay, remember, if you do sequence, suppose if you say sequence of 10, then it will give you 1 through 10. But you can also specify sequence starting from 5 to 10, then it will give you 5 to 10. Or you can say sequence 0 to 1, right? Then it will give you 0 and 1. But if you specify a third parameter, say 0.1, then it will start from 0, go up in increments of 0.1 to 1. So we can say here I want to go from 0 to 1 in increments of 0.1. So first time around for the for, cutoff will be equal to 0. And then it will go through this again, okay, and cutoff will be 0.1 and then 0.2 and so on. Okay. Now the for the for loop is enclosed by these squiggly brackets. So everything between the start and ending squiggly bracket will be repeatedly executed for the different values of cutoff. So I press enter, and so that's going to give me CM, and then that's going to give me the accuracy but I need to put the accuracy and somewhere and save it, right? So we have to set up an initial list. So let's say accuracy T for table, and then I just say C open close parenthesis. So that means at the beginning it'll be blank. There won't be anything. Okay, and then as you repeat, okay, so the accuracy T, I'm going to increment the list. So I take the accuracy T, okay, from before, and then increment the list with that as you go through this. Okay, so once that is done, then we can print accuracy T and see whether we have done this correctly. And there is one last thing we have to do. We have to bring that in inside the for loop. Okay, so for loop will start off with setting the cutoff value to 0, and then set up your predicted column using the cutoff, and then compute the confusion matrix, and then build the accuracy T. Then go back to the next value in the sequence, and now the cutoff will be 0.1, and then the predicted column will be set with cutoff equal to 0.1, and then repeat. Okay, now let's run this. Okay, so we have the accuracy values. Okay, so the warning message, we'll leave that aside. All right, so once you have this, then we can plot. Okay, so I'm going to use ggplot. Okay, so data for plot is, so we need the cutoff values and then the accuracy, right? So data frame, so cutoff equal to sequence 0, 1, 0.1, and then accuracy is equal to T. Okay, now let's run that. So data for plot, so we have cutoff and then the accuracy. All right, so then we can do ggplot data equal to data for plot. Okay, and then mapping equal to AES, x equal to cutoff. Okay, now we need two lines, one for accuracy and one for 1 minus accuracy, but they both use the same x, so we can put that in the base ggplot. And then we build the two lines. So we have geom line. Okay, so geom line mapping AES y equal to accuracy from the data for plot. Okay, now let's see whether that runs. Okay, so that's the top part, and then you add geom line Okay, mapping equal to AES, y equal to 1 minus accuracy. Okay, so they both are of the same same solid line. So if you want to use a different line type, then what you have to do is to add here within the AES. So this has to go inside AES. So it should be right after that. So there you say line type equal to accuracy, right? And here you say line type equal to error. Well, we need to specify the label inside. Okay, like that. Alright, so now if you run, so now you have the dotted line, and then you also have a legend indicating what is represented by the solid line and what is represented by the. So that's figure 5.4. So this should go right there.